Hi, and welcome to day 4 of MCAS BioFit Challenge. Today we've got a scenario, a female, and it doesn't matter if you don't know what the word is. I'm going to guess Hymenopepimachus wasp, but again, just focus on the fact that it's a wasp. Will temporarily paralyze a spider and then lay an egg on the spider's abdomen. After the paralysis wears off, the spider resumes its normal activity. When the egg hatches, the larva grows by sucking its required nutrients from the spider. All right, what type of relationship exists between the spider and the H wasp, we'll call it. All right, so in order to do this, we want to think about symbiotic relationships. And remember, there were 3 types of symbiotic relationships, showing an image here. We had mutualism, where both benefit, like your bee and your flowers, pollinating each other and giving each other food. Commensalism, where one is happy and the other is just not affected. And then third, parasitism, where one is harmed and the other is helped. Looking back to this question, commensalism, where we said it was a plus and a not affected, right? We'll put the null symbol. Mutualism, where they're both aided. Parasitism, where one is happy and gains and the other one is negatively affected. Or predator-prey. So it is a parasitism. All right? Question 2. A population of grasshoppers increased in size over a 5-year period. Which of the following best explains this increase? We're looking at population dynamics and what makes population size. Again, looking at this, I think we had a question a while ago on this as well. Births would increase it. Deaths would decrease it. Emigration, exit, would decrease the population, and immigration would increase it. Look back at that question again. Population increased in size over a 5-year period. So how would it increase? The death rate, which goes down, was higher than the birth rate. That doesn't make sense, right? The immigration that going into was higher than the death rate. And the emigration going out of, right, so that reduces it, was equal to the birth rate. So this one would show an increase. I'm going to put a question mark. The emigration, that's an exiting, was higher than the birth rate. So again, that's a negative number. The emigration, the exiting, was higher than the immigration. Again, I've got that number going down more. So the answer is going to be this one because my arrows up are where it's greater, and this one is kind of equal. Last question. A tactic for that one is to do increase arrow up, arrow down, or you could do plus minus. Now we're talking about Chargaff. So Chargaff is considered, Irwin is considered one of the pioneering scientists in the field of molecular biology. He helped to determine that structure of DNA. In one of his studies, he observed that a sample of human DNA contained approximately 30% adenine, 20% guanine. And remember, that's one of those nitrogenous bases. There's 4, adenine, guanine, thymine, cytosine. Based on the DNA structure, what are expected percentages of the other nitrogen bases in the sample? So in order to answer this, let's look at Chargaff's rules. Adenine must pair with thymine and in equal amounts. If you have a right shoe, you have a left shoe. Think of it that way. Guanine must pair with cytosine, and then that these bases form weak hydrogen bonds, attractions to each other. If the number of adenine is equal to the number of thymine, then the percentages will also equal. Looking back at that, adenine was 30%, and adenine pairs with thymine. So I'm looking for a 30% in thymine, which is this one. Cytosine pairs with guanine. And so again, I'm looking for that 20% to match, and I've got the match here. Just remember the rules: A to T, C to G, equal amounts, think shoes. See you at home for the fit portion. So didn't end up making it home today, so we decided to focus on something that's integral in both exercise as well as will be a really good thing for you for that MCAS test when you get nervous, diaphragmatic breathing. So we've talked about respiratory system, how that works and how the diaphragm plays, but a lot of people don't breathe properly. They do this, which is chest breathing. So we want to breathe through our diaphragm. So I'm going to have you do it. You could be sitting down, lying on the ground is a great place to do it. I'm just not dressed for that, but I'm going to show you it. So what you want to do is you want to place your hands around your waist, right around the belly button area. And as you breathe in through your nose, you want to inflate the tire and then exhale out of your mouth. Give a little resistance, and then that's how you do it. So the idea is you have a tire around your waist, and as you breathe, it expands, and as you exhale, it decreases. So again, watch that, and your stomach can get pretty large when you do this. But it's only temporary, so don't worry. And that allows a lot more oxygen to go into those lungs, increases lung volume, also helps increase parasympathetic activity, which will help calm you down. So again, in through the nose, out through the mouth, and have a great day. Practice breathing.